So, I was gonna pull up the introduction, which is so CodeQL tutorial. Yeah, that was where I was gonna start, just to kind of like get some people through. So this one is so this was Introduction to CodeQL. Find the thief, catch the fire starter, crown the rightful heir, and cross the river. So these, I'm gonna split screen this if I can. Come on. Yes, it's a little D&D adventure, but in CodeQL. And so I ran through this. This is like my experience with CodeQL is it started when I was doing open source security research across GitHub to I was looking for ways to find vulnerabilities in Maven POM files and Gradle build files, in particular the use of HTTP, and I found that the GitHub fuzzy search was terrible for finding vulnerabilities. And so I did that back in February of 2019, and when I heard that GitHub had purchased SEML as in one of their talks, I was thrilled, and so I jumped on it as a way of doing security research at scale in a way that lets you find vulnerabilities across like all of GitHub, all of open source, and I thought that was really really cool. However, when I first dug into it, I was like, wow, okay, I've got to learn this new language, which is this query language for finding vulnerabilities. Like, where do I even freaking start? This is a brand new language. And the nice thing about CodeQL is that if you have familiarity with Java, it traps you because it makes you think that it's enough like Java that you can get by, even though it's a bit of a lie. It's actually not like Java at all, but the Java syntax is a good like conceptual model to kind of it gives you a syntax to wrap your brain around, so that at least you're not fighting the syntax and the understanding of the language. So yeah, so if you have an internet connection, if you want to follow along, I'm just pulling up lgtm.com in one window, and then I'm going to pull up the tutorials in the other page. Oh, you guys, Xavier. So Xavier runs the GitHub Security Lab. He's in the chat. I just noticed that all these documentations now moved over to the github.com domain. So nice work. We're going to start out with the introduction to CodeQL. So, the query console is kind of like where you run your queries. Query. Yes, thank you. So, the query console is kind of like your starting place. It's the way that you can execute your queries. And one of the things that I've done for my account, and I have some scripts that let you do this, is by default you have to import the projects you want to run your queries against by hand, but I want to run my queries against thousands of projects, so I have imported like a boat. So yeah, I've imported a boatload of projects into my account, and then I realized this was getting out of hand because I was importing thousands of projects and this list got too long, and so I started deleting them from this list and throwing them into project lists, so I can run CodeQL queries against all of the projects that are for Facebook's open source projects, LinkedIn's, Netflix, Apple, Datadog, right, Spring, So I picked, in order to get the $1,000 bounty from Google, I picked my Google projects and I just checked that box, and then I ran this query against all of the Google open source projects in Java, and so that's how I tracked down these vulnerabilities. So let's start with Xavier. Is there a good project to pick that, like, is it good to pick a small project to run the samples against, or is there is any project the same amount of execution time?
No, your execution time will be in proportion to the build time, so I'd recommend to take a small one.
You have one in mind that comes in the demo projects down here that you suggest, or not a Java project?
No, nothing comes to mind immediately, so...
Alright, let's see. Do I have any like really derpy simple projects that like don't have much code? This one like doesn't have any code, I don't think. So if I do that one, that should be a very, very small database to be querying against, so it should be really fast. Okay.
Wait, Jonathan, in fact, you will not build it, right?
No, I'm not building it. I'm just running the query.
Oh, yeah, so the size doesn't matter here.
Okay. Great. Awesome. Awesome, awesome, awesome. Hey. So, also, questions are welcome. I'm watching the Twitch stream. I'm not watching any other streams. So, if you have any questions, post them in the Twitch stream. And also, there's a couple people on a Zoom call. Some of you have that link. If you want to jump into the Zoom call, I should be admitting people as if you want to hop in there and ask questions. So, this is the basic syntax. This is a query language. It has this syntax of like, okay, from where, like, so if you've written any SQL, you're familiar with this. Like, you're selecting a from, which is like the variable declarations, where a certain condition applies, and then what you're selecting, right? And so this is an example query, and let's just run this. So I have to import something as a base, and so I'm importing Java as the base, and then I can drop this in here, and it says from X. All right, so this should give us a result, which is a math. Yeah, so it should pump out a simple result. This is a little bit slow, unfortunately. There's probably a lot of system going on behind this one little button press. I can only imagine. Yeah, so great, 42. And so Xavier, please jump in here if I like totally butcher an explanation of anything, because I know that I recognize that I have like some probably misconceptions about how the system works. So these are a couple of like basic examples. I didn't actually go through these. I just I kind of like looked at the syntax and I'm like, okay, like great. Let's start with something practical. So they have this great example that is find the thief. So take on the role of a detective to find the thief of this fictional village, where you will learn to use logical consecutive quantifiers and aggregates in CodeQL along the way. And so the idea is, small village and there's a thief somewhere in this village. Try to figure out who the thief is based upon a bunch of questions that have answers, but you don't know who they are. And so you're trying to narrow down that superset into a subset. And so this is one of the basics that I kind of started with to get me. My project list is so tidy. That it wasn't like that. Trust me. That's not how it started. And so let's start with this. So there's a bunch of questions that we can ask, and there's some APIs. So I think that this works with the Java. I think I need to open the query console to get started. Let me make sure they don't give you some basic. Oh, I didn't want to. Okay, there's nothing that they give you for a basic. All right. Default the import language, select hello. Great, I can do that. So I think I have to import something, or does it come by default now? Let's just try this. Let me drop this in here. Yeah, there's something missing. Oh, here we go. Import tutorial. There we go. That's what I want. Okay. So what we've done here is we're selecting all of the people, or all of the persons, where their height is greater than 150, and then we're selecting those people. So let's just run this real fast to see what that does. And results. So there's 77 results and these are all the people. Now, similar to SQL, I could also say, so I'm guessing that the T, why this is not showing the whole record of the person, is because there's a two-string representation of person. So if I control-click on this, jump to definition, it is itself a string. Right. Interesting. This is, yeah. So there's a two-string representation, I think, somewhere in here that, no, I'm wrong. Okay, so because it's a string itself, that's what's printing. Okay, so what I can do instead, details. So I can also print the person's height. So if I do t.get height, this will print both the person and also their height, so we can see both of those at the same time in this table output. After writing my first query, I got a feeling that this is a kind of pruning of data that does not match to true with our query. Yeah, that's pretty accurate. Turn on, no, cancel. Oops.
Jonathan, I have a quick question.
Yeah.
How would you do this if you wanted to print out, like, Aaron is 176.6 units tall?
I think that it's like this. Aaron is percent units tall. Is this correct, Xavier? Is that going to work? Is
it should work, yeah.
Yeah, so that should do...
Or you can also concatenate the strings.
Oh, wait, concatenate? Oh, it's the plus operator works?
Yeah.
Oh, no, that's not quite working the way. Is it...
Oh,
So that should theoretically work. Let's see if that works the way that I expect it to. Yes. So there you go. I also got my spacing wrong, but so that's how you can you can do something like that. You can actually do string concatenation with query results as part of your selects.
Thank you.
Yeah. Okay, awesome. So we have these. So is the thief taller than 150 centimeters? Yes. So we have a where here, right? And then I can add an and, because we're going to do the next one. Does the thief have blonde hair? So the thief does not have blonde hair. So, and so we see down here that we have hair color, right? Get hair color on the thief, or on the person. And so we can do t.get. And so you can see that the autocomplete here, which is really spectacular. You can also do you can also use VS Code for CodeQL querying, and the autocomplete works there as well. And so we can see this, and this returns blonde. So this is, we can either do not equal blonde, and that should give us a few. Nope, that's not right. So it's not that. It's and not. There we go. And not equal blonde. Nope, that's height. No wonder I'm having problems here. Get hair color. Let's see. Does this work? Does this not operator and does not equal? Oh, okay. So cool. All right, we're doing type checking there. So this should work. This was one of the ones that was confusing to me. Is the thief bald? There was a question around. So start the search. So where's the best way to start? So this gives you the ability to do and or ors, right? Which is what we did here. So we've filtered down our results from 77 to 61 results. And then from here we have some things about where they live, which is down here. But let's do number 3. Is the thief bald? And so let's just read this. Predicates don't always return exactly one value. For example, if a person P has black hair, which is turning gray, P get hair color will return 2 values, black and gray. But what if the thief is bald? In that case, the thief has no hair, so the get hair predicate simply doesn't return any results. If you know that the thief isn't bald, then there must be a color that matches the thief's hair color. One way to express this in CodeQL is to introduce a new variable of type C and select those type string and select those T where t.get hair color matches a value of C. So what we're doing here, I think, is we're saying that there must exist a C string. So in the like full superset of all strings that can exist, right? There must be a C that exists, right? Um, and so because we're saying that the thief is not bald, right? Then we can put an and of t.get hair where the hair color must exist. There must exist some C where get hair color is returns true, right? So you're not bound, you're not restricting what C is. You're just saying that get hair color must return something that is a string. It can't return nothing. Which is weird. So if we do this, this should further reduce the result set that we get. Hopefully. All right. Awesome. So that will result, I think we were at 66, and now we're at 61. So is the thief younger than 30? No. So there we have an age, right? So and t.get age is younger than 30. So they're not younger than 30, so they must be greater than or equal to 30. Is the thief younger than 30? No. Must mean that they are greater than or equal to 30. Yes, I think that is accurate. Let's also, just for a sanity check, and is t.get age years old. Sanity check myself. Okay, we're down to 48. So, and is 49 years old, and is 76 years old, and is 37. I don't see, let's see if there's anybody 30 years old showing up in this list. No. Well, that's okay, though, because we're saying greater than or equal to 30. Does the thief live east of the castle? So, that one is just another and then t.get location equals east. Let me just check this real fast. Hang on one second. Let me. Oh lordy. Sorry, somebody pinged me real fast. Oh, Zoom's getting in the way. Forgive me, this is the... Okay. Cool. Hang on one second. So, okay. So we filtered down to 48 results. Does the thief leave east of the castle? We said yes about that. Does the thief have black or brown hair? So for this one, I think that this one requires the OR syntax, but I think there's a way to do this with an array. But I think that for simplicity's sake, we'll do it with the simpler state. Oh, interesting. Okay, so let's jump back to this let's jump back to this C case. So right here, what we're doing is we're selecting all C's out here at this scope. So we don't need it quite scoped that widely. So we can restrict the scope of this C to be slightly smaller if we do something like this. Oh, come on, shift. Okay. Exists string C, and then where this condition exists. And so I can then drop this C here. And so then we're not selecting it for the entire scope. It's just being used in the single scope that we need it for. That's what this section. Exist introduces a temporary variable C of type string, and it holds only if there is at least one C string that satisfies t.getHairColor equals C. There's also for all and for x all. I have not dug into what those actually mean. Universally qualifiers, which is logically equivalent to not exists. Formula. I do not have a grasp of that. I will have to understand that a little bit later. Set literals. Yes. There's not enough use of set literals. I've noticed this you look through the CodeQL database. For people that have actually looked through the CodeQL database, there's not enough uses of set literals. There's a lot of repeated code in a lot of places that doesn't need to be repeated. Okay. Oh, am I looking at the wrong investigation? Start the search. The real investigation. Okay, here we go. Oh, is this the same? Okay, the real investigation. Using the examples above, are these the same, Xavier? Are these the same set? Are these different things, just to confuse you?
Wait, I think... Well, I think they seem to beat the dog.
Alright, well... Let's see. Does the thief have blonde hair? No. Okay, we got that one. Is the thief bald? Okay, we got that one. Age is greater than 30? No. Does the thief live east of the castle? Yes, so we have that one here. Does the thief have black or brown hair? So let's do that one real quick. So, t.getHairColor equals black or t.getHairColor equals brown. So that should also further restrict our results, theoretically. Invalid query. What have I done wrong?
You're missing an and above.
Ah, yes, I am. Thank you. Trigus, you're an old hat at all of this. I've seen you've got at least 1 or 2 bounties under your hat for this language. Okay, so we've gotten down to 10 results here. I need to make sure that for Zoom, is there anybody that's waiting to get in? I don't think so. Okay. So we're down to 10 results, so we're getting there. Is the thief taller than 180 centimeters and shorter than 190 centimeters? No. So, I think that the way to do this is and not, and then we'll put the statement in here. Well, actually, let's move the not down here. How can I do this? Okay. And not t.getHeight is the thief taller than 180 centimeters and shorter than 190 centimeters? So no. So we're gonna put a not in front of this, but we're gonna establish that this as a yes case. So is the thief taller than 180 faller. I got this. And t dot get shorter than 160. 190, sorry. All right, so let's add that. And then there's a thief, the oldest person in the village. That was the one that needed a little bit more clarification. And so this one is one of the difficult ones that I am going to need some help with. So, is the thief the oldest person in the village? No. So, we still have 9 results, right? You'd think that they would give you down to 2 at this point, right? Like, is it the oldest person in the village? Let's look into down here. More advanced queries. So we want to find the oldest person in the village, right? So is the thief the oldest person in the village? So we need to know who the oldest person in the village is, which looks to be 68 years old, but like let's assume that we don't have that information here, right? So, for example, you can use max aggregate to find the age of the oldest person in the village. This aggregate considers all I, limits I to the values that match the ages of the people in the village, and then returns the largest matching integer. But how can you use this in your query? So this is how you'd select this, right? So where get age, and then you select that there exists a person where you bind I is coming here, right? So I is bound here. Xavier, can you explain this I here? Why do you need this outer I here?
Wait, so here in fact, this one gives you the result expression, right? In the first part, you declare the variable.
Yep. So that's this part's the declaration.
Yes,
yeah.
That's just a declaration.
Yeah.
This one is the binding.
Yep.
Part. So that's the logical formula.
Yep.
And then you get the expression at the end. So you could, for example, here have more than I. You could have like any formula, right?
So you could return from this function. So that's what the max will return. So if I said yes. I plus 1, the max will return I plus 1.
For example.
Okay. Interesting. Thank you for that. So let's do this. So this will give us so this says select where the age is equal to the maximum age of the person in the village, right? The problem is that what we want is they are not. Is the thief the oldest person in the village? No. So we want to find the person that is not the oldest person in the village. I don't think this is going to give us what we want. I feel like I'm missing something somewhere. So we will find out. I still have 9 results, so I have missed something somewhere.
I believe that the oldest person in the village is Susanna.
Yep.
Who has already been crossed out. What I did is I returned T and the oldest person in the village by selecting the maximum.
So you wrote you ran it as another query?
I actually didn't run it as another query. I just added like another item in the select line.
Mm-hmm.
So at the very end, just do comma, and then return the select max open paren, person P.
Wait, in the select, you have another select?
Yes.
You can do that?
Maybe.
Okay.
Oh, no, I didn't use the select keyword, sorry.
Okay.
It's actually, if you scroll down a little, it's on the investigation page. It's right after it tells you about the general aggregate syntax. Yeah, that's that second select.
This one right here.
Exactly.
So, for example, selecting the oldest villager becomes much simpler if you use an ordered aggregate. The ordered aggregate considers every person P and selects the person with the maximum age. In this case, there is no additional restrictions on what people to consider, so logical formula clause is empty. Note that there are several people with the same maximum age in the list. Note that if there are several people with the same maximum age, the query lists all of them. Okay, so it gives you a result with multiple things. So what I'm hearing that you are saying is that where not equals this.
I actually, that might have been the better way to do it. I just returned it as I returned the oldest person and just manually looked and said, oh, Suzanne is not on the list.
Oh, so you then hard-coded it in your query? Makes sense. Okay, so let's try that. I think that I'm missing something else somewhere else. So I'm still at 9 results, which is exactly the same as I had before. So, all right. Oh, wait. Capture the culprit. Wait, okay, so this is not going to give us all of them. Wait, once you finish, you will have a list of possible subjects. One of those people must be the thief. Okay, so we're not done yet. Great. We have additional query. We have additional. Additional things to capture. Is the thief the tallest person in the village? Is the thief shorter than the average villager? Is the thief the oldest person in the eastern part of the village? Oh, good lord. So syntactically, this is where my brain kind of gets a little bit hurt. So, all right. Is the thief the tallest person in the village? So we currently have the person with the maximum age. So we can probably repeat this similarly for the person that is not. And is the thief the tallest person in the village? No. Okay, so the tallest. So we can do order by get height. Let's try that. That should reduce. Yes, thank you. Yeah. All right. Hang on 1 second. So while that's running real fast. Come on. Hang on 1 second. I have too many windows and too many things going on all at the same time. Okay. So we're still at 9 results, which is great. So we've already filtered that down. Is the thief shorter than the average villager? Yes. So now we need to average the height of the villagers. So I think that we need to get the average here, and so we can't use this syntax because we can't grab the average person because that's not valid. We need to grab the average height of the person. Here we go. Gets the average height of the person. Great, that's exactly what we need. So, yes. So, is the thief shorter than the average villager? Yes. So, we do an and. T dot get height. If that is, so they are shorter than the average villager. Yes. So if their height is shorter than the average villager, we should be good. Run that. That should theoretically reduce the number of results again, hopefully. Fingers crossed. Okay, we're at 6 results. So we've dropped it by a bit more. Is the thief the oldest person in the eastern part of the village? Oldest person in the eastern part of the village. So we know that they are in, their location is in the east. So their location is in the east, which we already have captured, which is a yes here. But we also now know they are the oldest person in the eastern part of the village. So we want to get the... Oh, that's weird. Okay, so we want to get the person. We want to get the person, woman, camera, TV. No, wait, that's sorry. Wrong, wrong reference.
Jonathan,
yes.
Look at the predicate where you were looking at the max person. The max, the older person. You will see that the second place, where there is the logical formula, you didn't put anything because you wanted to get all of the villages.
Which are you talking about in my query over here or in the documentation on the right?
In both actually, but in your query, line 11.
Okay.
Yeah. So here it's blank because you want to get all the villages. But if you want to restrict this population, then you can put here a logical formula.
Okay. All right, that helps. Thank you. So, hang on 1 second. Oh no. the computer that I've been using for watching the Twitch stream has died on me. Give me a moment. Technical issues. Fun times doing it live. Dropping a layer. Okay. Alright, cool. Sorry, Twitch stream, I have totally lost connection to you, so I'm going to boot up my computer and I'll be back shortly. This Twitch stream is still running, it's just I can't see the text. Log in. Great. Okay. Awesome. So, we can put in a predicate here, which will give us the person. So, the oldest person, so we want to find the oldest person where predicate is matched. So, and T equals the person that is the oldest person. So we want the thief is the oldest person in the eastern part of the village. So T equals the person with the maximum age where the P dot get location equals east. From that, let's see where that gets us.
So, Jonathan, are these queries ordered in any particular way so that selecting your maximum age after selecting East would generate the maximum age within the Eastern Village, or are they somewhat concurrent and you can't guarantee it?
That is an excellent question that I do not have the answer to, but Xavier, you probably maybe know that one?
Can you come again, please? Since I didn't.
Sure. I was wondering if each of these clauses in your where statement are ordered strongly so that asking for the maximum age person after you select your Eastern Village qualifier would generate the maximum age within the Eastern Village, or if these are kind of disparate.
So
if they don't guarantee order.
So here you just have okay. So you are saying, are you talking about the orders of the different lines inside the where? Does that matter?
Yes. Yes. So each of those ANDed statements.
Yeah. So in fact, what will happen is that the compiler basically will do the job for you. The technology behind that, one of the power of the technology behind that is all included into the compiler, who will get these queries and who will optimize as much as it can the final query that will be run, right? So the order would not matter here.
Okay, so
Okay.
There's no there. You prematurely optimizing your query to like try to reduce the number of results earlier in your where clause is not going to optimize the overall amount of data that gets queried, because it's just gonna all get kind of mushed together. Or the compiler is smarter than you are potentially.
Yeah, well, there are cases where you will be able to mess with the query and get too many results or infinite tuples, right? So you will have to be careful about that. But for these simple cases here, right, where you have just this and this and this and this, then the optimizer will do the work for you.
Cool.
Right. The cases where you will be able to mess the things in is when you will have, I don't know, you will really be able to get some scalar products of two big sets of variables.
So when you're not just comparing against a single table, but when you're doing like comparisons across tables, basically is where those optimizations come into place.
Yeah, typically.
Okay.
So not even including optimization here, but just in a pure logic sense, I guess I'm primarily focused on the maximum statement here, where we are adding the variable and getting something out of it. In each of those, that maximum will depend on, or do they depend on the previous clauses that you've set? Because the maximum out of all of the 30-year-olds or maximum out of the under 30s might be different.
I think I can answer that. So, all right. So this query right here is scoped to this max. So basically, you're not looking at all the people from type T. You've created a new person query where you're re-querying the person table and restricting that set and getting getting another person out of that max, right? And so this query is running against that same table and doing another restriction of that set that is a different look at the table that this outer one is doing. Is that accurate, Xavier?
Yes.
Okay.
Okay, perfect. Thank you. That was
Yep.
well explained.
Yes. So all right. So we seem to have found Hester, the thief. Let's make sure that that's actually right. So I'm running their query. So this is the query. This is the query that I came up with. This is the query that they suggest. It seems like we've kind of aligned. Let's see. The exists is so this is also an exists. And exists person. Interesting. So this one is.
Yeah, this is what I wanted to tell you. So there are several ways where you could write your query, right?
Mm-hmm.
And for example, if you look at, I'm not the older person in the village, then you can express it by saying there is someone older than me.
Right? So I've conveyed the inverse of it.
Yeah, I mean, so you were saying I am not the older.
Yeah.
And you could express it with there is someone older than me. Right.
Right. Yep.
It's exactly the same, and in this case, for example, I think that the compiler will convert that into exactly the same SQL query at the end, right? So you don't need to care about that, but you can really play with the way you express things to make the query more readable for everyone. Make it more expressive. Right.
So, I mean, most of this is all syntactic sugar over an actual query that gets generated against an actual database, right? Like most of this is just sugar mostly, yes?
Well, yeah, you could say it's sugar, but the way I would say it is that it gives you a way to express the thing so that a reader could really understand what you're trying to do, right? And,
That's the most important thing, especially given. So some of these queries get very, very. I mean, so this is a very basic usage of this language in this query syntax. This language goes way beyond this. This is a very basic kind of like. It gives you a perspective around how this can be used from an SQL kind of perspective. So if you're coming into this with SQL, right, this gives you that kind of angle. But there's a bunch of really powerful things here that we'll get to around like data flow and graph traversal stuff that like all happens behind the scenes because of a lot of very smart people having done a lot of very cool things already. This is just to kind of wrap the syntax and get us there. So we seem to have found that Hester was indeed our thief. Let's move on next to the catch the fire starter. I think this is where we start introducing predicates. And so what we've looked at here is like this from where select sort of stuff, but there are higher level concepts on top of this language, like classes and methods ish. They're actually predicates. They look like they appear like methods, but they're actually predicates. And so we can leverage these to simplify our code overall and make these fairly complicated queries with some fairly basic building blocks that help build up our queries in repeatable and in simpler ways. So you've successfully found the thief and returned the golden crown to the castle, but another terrible crime is committed. Early in the morning, a few people start a fire in the field north of the village and destroy all the crops. Now you have the reputation of being an expert CodeQL detective, and so you are once again asked to find the culprit. This time, you have some additional information. There's a strong rivalry between the north and the south village that you know, and you know the criminals live in the south. Read the examples below to learn to define predicates and classes in CodeQL. These make the logic of your queries easier to understand and will help simplify your detective work. That is very true. These concepts make working with CodeQL significantly easier. So, I'm gonna quickly. I'm just going to throw this into a GitHub gist, and I will post it in the Twitch stream. If you want it, you can have it. There's also the results that... I'll post this in the Twitch stream so that people can find it if they so desire. Come on. Create public gist. There we go. Alright, let me open up the Twitch stream real fast. Let me paste it there. Pull that over here. Oh, that's not what I wanted to do. Yeah, man. Pull that over here. Oh, lordy, I'm hearing myself. Okay, where's the chat? Come on, chat. Where are you? Oh, come on. Can't find my own buttons. There we go. Expand. Okay, there we go. That's in the Twitch chat. Can I not link? Can I not? Oh, you gotta be kidding me. Okay. I can't seem to be able to post my own link in the Twitch chat for some godforsaken reason. Creator dashboard. Stream manager. There, we can probably do it from there. Send message. There we go. Ah, awesome. Okay. So it's now in the Twitch stream if you want it. What even? I have way too many. Oh yeah, this is a local. This is a vulnerability I found with CodeQL. Fun story. In Netty. Okay. So I'm gonna delete this. And let's do the next one. So yeah. So let's take a quick look at this. This is a very simple predicate. It's is Southerner, right? And this time you only need to consider a group of villagers, namely those living in the south of the village. Instead of writing get location equals south in all your queries, you can define a new predicate is Southerner. The predicate is Southerner takes a single parameter p and checks to see if p satisfies the property. And so one of the things that you can do with CodeQL, this is where we start getting into some really powerful functionality and features of CodeQL, is you can declare a class Southerner. Southern. Can I spell? I cannot spell. Please forgive my poor extends. And what's actually happening here is really interesting, is I'm not... So if you think of traditional object-oriented design analysis and object-oriented design whatever, traditionally when you declare a class that extends another thing, you mean that you are creating a type of person, or a type of thing that extends that. So like, you know, a dog is a type of animal, right? And in the common pattern of like the common way you think about like object oriented, right? You can't like have any animal can't be a dog, right? But in this case, I'm not saying that any animal is a dog. What I'm actually saying is I want to restrict the type of person that is to the type of people that are Southerners. So so what I'm doing here is there's this like thing that looks like a constructor, which you can kind of conceptually think of as a constructor, because what it's doing is defining like it's defining what characteristics this person has to make them a Southerner, but you never like construct a Southerner. It just exists, right? It exists, and the query language gives you a Southerner based by giving you all of the people that match the Southerner condition, right? And so in our case, I can't spell, and my brain is tired. So what I've said here is that any person. So what I've said here is that A southerner is anybody that is a southerner. But so they're a person that isn't a southerner. And so the interesting thing I can do here is that I can do select southerner. I'm not, this is a terrible, can't spell southerner. S. And so when I do this, so from, there we go, from southerner, select S. And so what this will do is it'll give me all of the people, all the southerners that match this predicate. So it's really, they're all these people. There's all these people, but I'm asking for just the southerners, which is a subset of those, right? A class in CodeQL represents a logical property. When a value satisfies that property, it is a member of this class. This means that the value can be many classes. Being in a particular class does not stop it from being in other classes too, right? So just because I've restricted the number of people that are southerners does not mean that I could not define a person that is also tall, right? And I could then write from southerners S and southerners tall and do an equality check on the two of them and find all of the southerners that are also tall. And that would give me all of the people. That's a lot. So let's work through this. You always need to define a class in CodeQL in terms of existing larger class, right? In our example, southerner is a special kind of person. So we say that a southerner extends is a subset of a person. You may have noticed that some predicates are appended, for example, p.getAge, while others are not. For example, is southerner. This is because getAge is a member predicate, and that is a predicate that is only applied to member classes. So you can define predicates, right? So I can do predicate is tall on person and define something that it is tall, and so then I could do southerner dot is tall on, and I could do like where southerner s dot is tall. Is that, yeah? So that's how you get the difference between those two things.
Just one thing, Jonathan. If you had created a correct historical predicate, you would have benefited from auto-completion. As soon as you create new classes, new predicates, you get auto-completion, which solves a bit your spelling issues.
Yes. Yes. Okay, so another factor you may want to consider is the travel restrictions imposed following the theft of the crown. Originally, there were no restrictions on which the villagers could travel within the village. Consequently, the predicate is allowed in string region is held for any person in any region. The following query lists all the villagers since they could all travel to the north. Okay, so what we want to do here, right, is that because there was travel restrictions due to the theft of the crown from our previous find the thief, the person that started the fire could only have been allowed in the north. So where S is this correct? Okay. However, because we don't have the is allowed in, we're going to define the is allowed in. This means that is allowed in no longer holds for all people in all regions, so you should temporarily override. Wait, what? I'm confused. Does person not have is allowed in? Okay. Okay, so this is a predicate that exists, right? The predicate is allowed in, and so by default, in the default state, all people were allowed in the north, south, east, or west, right? Yes. Okay. So is allowed in. So this is the default state. What we are going to do is so I'm looking at the definition of is allowed in on person. We are going to override is allowed in our class. So override is predicate.
Jonathan, I think you have
I have a syntax. That's
superfluous
semicolon.
Yes.
Thank you. No wonder I was having auto-completion issues. Also, the autocomplete in VS Code is actually better. In my experience, the website's pretty good, but I when you get into IDE, it's actually much better. So start by defining a class child containing all villagers under the age of 10. Then, okay, wait, what are we doing? After the recent theft, the villagers have become more anxious of criminals lurking around the village. They no longer allow children under the age of 10 to travel out of their home region. That means that is allowed in region no longer holds for all people in all regions, so you should temporarily override the original predicate if the person is a child. So we want to define a child. I'm going to do this down here. Child. I'm actually going to just copy this because this is stupid for me to type out myself. I don't need to do this for the Southerner. And so this should, so you see we have 23 results for all the Southerners. If I run this, this should give us, purely the existence of this should restrict, yes, okay, so we were at something higher. We were at something higher, 60, 20 something, and now we're at 17. So by defining a class that extends person, we've defined that all children, so anything that matches the child predicate, there, when you call is allowed in on that child, that will return false. Is everybody still with me? Okay, judging by that, yeah. This is one of the things that's used to great effect when you're writing future CodeQL queries. So does this all? Are we like, yeah? Everybody good? Please speak up if you don't have any questions here. This is a little bit wacky. Okay. Okay, so you now know the Firestarter lives in the south and that they must have been able to travel to the north. Write a query to find the possible suspects. You can also extend the select clause to list the age of the suspects so that you can clearly see the list of all children that have been excluded from the list. Let's open up this query real fast. So yeah, so we have the same 17 results. Great. You can now continue to gather more clues to find out which one of your suspects started the fire. Identify the bald bandit. You ask the Northerners if they have any more information about the Firestarter. Luckily, they have a witness. The farmer living next to the field saw two people run away after the fire was started. He only saw the tops of their head and noticed that they were both bald. This is a very helpful clue. Remember when you wrote that CodeQL query to select all bald people? To avoid having to type that whole thing every time you want to select a bald person, you can instead define a new predicate called isBald. So we can copy this. And because it's unused, we get a warning there. And they said they were both bald. Okay, so we also know and is bald. So you notice that is bald accepts a person, right? But Southerner is a superclass, so you can still pass is bald. You can also still pass Southerner into an is bald because of that relationship. So we should. Great. So I think the result is Charlie and Hugh here. So let's see if that result matches up. Charlie and Hugh. Awesome. Okay. So that kind of gives us a basic understanding of extension and stuff like that. Let's jump into the crown the rightful heir real fast. Okay. Are there any questions before we move on? Anybody, anywhere? In the stream or in the Zoom? Great. Great. We have no more crimes in the village. You can leave the village and go home, but then during the last night in the village, the old king, the great King Basil, dies in his Basil, B-A-S-I-L, dies in his sleep, and there's chaos everywhere. The king never married and had no children, so nobody knows who should inherit the king's castle of fortune. Immediately, lots of villagers claim they know they are they're somehow descended from the king's family, and that they are the true heir. Oh yeah, this is the complicated recursive queer. I still haven't wrapped my head fully around this one. So hopefully, Xavier, I won't be needing too much help. But eventually you decide to stay in the village to resolve the argument and find the true heir to the throne. You want to find out if anyone in the village is actually related to the king. This seems like a difficult task at first, but you start work confidently. You know the village is villagers quite well by now, and you have a list of all of the parents in the village and their children. To find out more about the king and his family, you get access to the castle and find some old family tree. You also include in the relationship in your database to see if anyone is the king's family is still alive. The following predicate is useful to help you access the data. So let's drop this one in real fast. This is going to dump out just a boatload of data. $117 results. I'm not looking through all of that. Okay. There's too much information to search through by hand, so you write a CodeQL query to help you find the king's heir. We know the king had no children himself, but perhaps he had siblings. Write a query to find out. So we're looking for a person where the parent of P equals the parent of King Basil, right? So we're looking for a... Yes. So we're looking for the siblings of King Basil. No, wait.
Yes.
Yes. No, sorry. We're not looking for the. We're not looking for the parents of King Basil. What we're trying to find is siblings of King Basil, because this will pick. So this will give us the parent of King Basil. Or sorry, of P, and this will give me the parent of King Basil. Why do we need this not, though?
Well, to exclude King Basil, because the parent of King Basil is the parent of King Basil.
Ah, thank you.
Want the siblings.
Yeah, you don't need the king himself. Yep, yeah, that makes sense. Oh. So we have 4 results. But you need to check if any of them are alive. Here's one more predicate you might need. So are any of them and not oh, the syntax here. Sorry, the form, yeah, and not P dot is deceased. Is uppercase. Well, that's because... So, here's the odd one. Person extends from string, so that's why you have the is uppercase method on it. Weird relationship there. You need to extend from something, and the base types are strings, and yeah. So nobody's alive. None of his siblings are alive. Time to investigate further. Might be able to define a predicate child of, which returns a child of the person. To do this, parent of predicate can be used in the definition of child of. Remember that if somebody's a child of P, if and only if P is their parent. Okay. So here, this is not a predicate. This is returning a. This is a function. Right? As illustrated above, you don't need to directly write result equals expression involving p. Okay. I have been very confused about what Xavier. Can you provide some context around? So result is a keyword, right? So can you like kind of clarify what result is in this context and like how it like what is it? Is it a person? What? Yeah, just like kind of yeah.
Yeah. So here, as you said, it's this particular predicate is a kind of a function, right? So it should return something, okay? But here the syntax is not that. It's not like result equals blah blah or you declare something and you say return the thing, right? You just because we are talking about logical programming and about predicates, you just create this predicate and you just write down the logical relation, right, between your variable, this p, and between your result. And then this function will automatically return result, right? So yeah, result is the keyword, and you just have to define the relation. So p equals parent of result, and you don't need to do anything like return result or result equals something.
So I think that another important thing to recognize here is that so if it's a child of person, right? This, even though it says that it's returning a person, the child of person, there can be multiple children. So this is actually this looks like it's returning only one, but it can actually be many or none or one, right? It's not actually it's a set.
It's a set.
It's a set.
Return you the complete set of a person that verifies p equals parent of this person. Right?
Yes. Okay. Everybody's still with me, or with Xavier, or with somebody. All right, cool. To write a query to find out if the children had, if any of the king's siblings have any children, we can use this. So let's drop this.
So as you can see here, the select child of p. So child of p returns a set of children of these of all these persons.
We don't get any. We don't get any at all because there's no children of the parent of King Vassal. So this is getting complicated, right? You want to find a relative of that lists all of the relatives of P. So we're looking at a tree, right? At this point, you're doing tree traversals with logical components. So it helps to think of a predicate definition of relative. A possible definition is that two people are related if they have a common ancestor. You can introduce a predicate ancestor of person that lists all the ancestors of P, and an ancestor of P is just a parent of P, or a parent. An ancestor of P is just a parent of P, or a parent of a parent of P, or a parent of a parent of a parent of P, and so on. Unfortunately, this leads to an endless list of parents. You can't write an infinite query in CodeQL. You can't write an infinite CodeQL query. So there must be an easier approach. Aha, you have an idea. You can say that an ancestor is either a parent or a parent of somebody you already know to be an ancestor. You could translate this into CodeQL as follows. So this is a recursive as you can see here, we've used the predicate. So this is a recursive, right? You can see you can use the predicate ancestor of inside of its own definition. This is an example of recursion. This kind of recursion is this where the same operation, in this case parent of, is applied multiple times, is very common in CodeQL, and is known as the transitive closure of the operation. And this is at the point where I glaze over and lose my brain. There are two symbols, plus and star, that are extremely useful when working with transitive closures. Parent of plus applies the parent of plus predicate to p one or more times. This is equivalent to ancestor of p. Parent of star p applies the parent of predicate to p 0 or more times, so it returns an ancestor of p or p itself. Using this notation, define the predicate relative of and use it for all the living relatives of the king. Hint, here's one way to define relative of. So, Xavier, at this point, my brain, this is where my brain just gets lost in the CodeQL, and I have no idea. Like, at this point, I just grabbed the example code, but is there like a ELI 5 break it down kind of thing that you can do here?
Well, how can I do that? Well, honestly, it's really just taking what you have here as example, what you have highlighted, this ancestor thing, right? This is exactly what you would do if you, well, when you code a recursive function, right? This
yes.
Is clear. Okay, so then this plus and star is just some sugar that allows you to write that easier, because indeed we use it a lot, right? When you are tracking function calls, when querying your code or stuff like that, you need this kind of stuff. So so as we use it a lot, we don't ask you each time to write the recursive equivalent of that, and we provide you with this plus and star to really just replicate the thing that you have highlighted here.
So the star version would just be the star version is equivalent to this, right?
The star version is equivalent to this, or result equals p. This is the plus version.
This is the plus version.
Yep. The star version gives you also the 0 calls, so meaning result equals p.
Okay, so you get so basically, so the star version gives you result equals p, or that's the result. That's the plus version.
If you add result equals p, then it's the star version.
This is the star version.
Yeah.
And this is the plus version.
Yes.
Okay. Okay. I think that would be I think that this documentation right here would be useful to convey, like, you can think of this as equivalent to block of code, or this as equivalent to block of code. I think that in this bit of documentation right here would have helped my brain initially kind of wrap around this concept. Yeah. Because I just reading the text did not translate in my brain. So, yeah. little bit of feedback. So, I think that what we can do here is we can just use, try to define a predicate relative of and use it to list all of the living relatives of the king. So, ancestor of, all right, I'm going to open it up to the rest of the audience. Anybody got an idea how to write this? Seth, Sarah, Rox? Marcy?
I got nothing.
Fair enough. You want to walk us through this one, Xavier?
Yeah, so you don't need any more ancestor auth, right? Ancestor auth was just an intermediate step to get to the ancestors and then being able to get back, get down to the relative.
Yeah.
You can write the relative directly by, okay, so what's a relative, right? Well, I'm related to someone if somewhere in our trees we have a common parent.
Yes.
Right? And the common parent doesn't need to be at the same level, right? It can be, because it can be your uncle or something like that.
Yes. So
basically you need to say that one of my parents is also one of your parents. And this way we are relatives.
So this is one. So this is one way of defining this predicate right here. But so wait. So what? There's two stars here. So either yourself. So this would return yourself, though, would it not? Right. The person passed would be part of the result set.
Yes, I'm a relative of myself.
That is okay. Sure. Yep, that is fair.
But we need that because if I'm your father, I'm a relative also, right?
Yes.
So this is why I need to take into account myself in the chain.
Okay.
Or yourself.
So. Am I thinking, so okay. But I also need to filter that the person, no, so
you need to get rid of the previous filter because
yeah.
you will just, looking for siblings here.
Yeah. So I need where P equals Is that a reasonable way of writing this?
Yes, and you need to filter out the
and the dead ones, yeah. I can spell. Oh, come on. Is deceased. How are we doing on time? 7:11. And not. Is deceased. Great. So we have two. At the next village meeting, you announce there are two living relatives. To decide which should inherit the fortune, the villagers clearly read through the villager constitution. The heir to the throne is the closest living relative to the king. Any person with a criminal record will not be considered. If there are multiple candidates, the oldest person is the heir. Didn't we already... as you found in your previous challenge, define a predicate has criminal record, so that it has criminal record P holds if P is any of the criminals you unmasked earlier in Find the Thief and Catch the Fire starter tutorials. So has criminal record. Oh, good lord. That's a So I think that Hester was the one that we found was the fire starter. But let's just do this as a so predicate is criminal record. My keyboard is disconnected. Oh, there we go. So let's take that previous query. And let's do exists person T oh okay, I can't auto format in here. Not P equals is it not exists?
No, I think that you want to look for this person that you had already, and to say that this person is the fifth one, right?
Yes. So exists, right? So then has criminal record T. Oh, so I want to do and T equals P.
Yep.
What I need to do, I'm just gonna, I have to create another, I have to change the variable so I'm not conflicting with another thing. Alright, so that's the first one.
So, wait, so, yeah, okay.
Yep. And the other one was the Firestarter one, which I'm not going to pull my own. I'm going to go down here, see the answers in the other one, pull this query. Yeah. And then I'm going to do another exists, and just to keep it simple, exists person T, oh sorry, this is an or person T this is allowed in, no, person S, and T, and S equals person. And then so, and not has criminal record P. Let's try that out. And then I think that we're probably going to call it quits in terms of these tutorials. Unless Cross the River is really short, I'm not going to go through all this, but I will walk you through some of these existing CodeQL queries that I have written as like a high level, like cool things you can do with CodeQL when it comes to actual code and see some actual proper applications of it in like a high level, like we don't have to think really hard, which I think that some people will enjoy. And as a result of our query, we found that Clara is our true heir to the throne. And let's just run this. Oh wait, did you already this well, that's another way of writing it, is just excluding Hester, Hugh, and Charlie. Thank you very much. Okay, my has criminal record is much more complicated. Fair enough. Okay. Cross the River. I'm just curious, I've never read this one.
So you know, it's the typical puzzle of, you know, the cabbage, the wolf, and the
the cabbage, the wolf, and the goat problem. That can be encoded in CodeQL.
Yeah. So do it for fun, but I think that now it would be more interesting to see real code examples.
Yeah. Okay.
Yeah.
So let's dive in and look at some real code. So let's look at my first CodeQL example, or the first real CodeQL query that I ever wrote, and submitted as a bug bounty for GitHub. So Netty this is the first query that I ever wrote. So Netty is a Java library. And there's a vulnerability in the HTTP standard where if you are building an HTTP request, so the HTTP spec is the header of the HTTP body is so the header of the HTTP spec is a bunch of data that gets written out to a socket eventually, right? Like it all of the protocols that we deal with are all get down to like a bunch of like raw strings in a socket being sent as data. In this case, the HTTP spec, and the way that the HTTP spec works is it deals with it's new line delimited, but it's not just new line. It's new lines. It's the Windows control line feed character followed by a new line character. That's how the HTTP spec is delimited. And so if you have a library that builds an HTTP request header, but it doesn't sanitize the CLRF characters, you can inject additional data into that HTTP header. And so it can lead to various different vulnerabilities. There's two main ones that can result in. One of them is HTTP request smuggle, or not HTTP request smuggling. Well, that's one of the results, but HTTP request header injection, or it's called CLRF injection. But basically, the result of that is that. So let's say you have a server that responds to a client with data. If you have user supplied data that flows, for example, into the creation of a header, right? But that header is not sanitized correctly. An attacker can use that to inject line feed characters and add their own headers to an HTTP response. And doing that, they can do cache poisoning. They can get cross-site scripting. If they send enough data, they can actually get code into the HTML body of the web page that gets returned. And because of caching, like all the layers of caching that HTTP servers do, you can actually poison a cache and you can get persistent cross-site scripting. That basically means any time that somebody loads a website that's got a cache vulnerability, or that has one of these vulnerabilities, you can constantly get XSS cross-site scripting across, like, everybody that views that website. So you don't just need to target a single person. You can poison the cache. And so Netty has this vulnerability where if you disable their validation, which is a stupid flag, you set it to false in one place. You set the wrong constructor to false, and this validation gets shut off. And at that point, this vulnerability exists. So let me look that up. Netty, not Netty. There we go. So this was the first vulnerability that first CodeQL query that I ever wrote. The query is actually pretty simple. It started actually significantly simpler than this. And so what I'm looking for here, let's look at a couple of examples of this, just to kind of start from somewhere. So the way that this looks, and these examples are not actually vulnerable because they do other things that are saving them. But the issue arises is when you call this constructor and this last argument is false. That's the vulnerability, basically. Because then if you use this HTTP response object with user supplied data, you have a vulnerability. So you can do with CodeQL tracking to see if user data actually flows to the use of this thing. I didn't do that because just in the general case, don't disable this validation unless you know what you're doing. Which I've checked through all these cases and they're good, but I still wouldn't recommend it. And I also need to report this in the Netty team. I've reported this in the Netty team saying why? Why do you have this false? It opens a vulnerability. But so I digress. So this vulnerability, so as an example, I'm looking for constructors. And so in Java, you have a class instance expression. So this is an expression of an this is the a class is being instantiated. So it's a class instance expression. Yeah. So it's the create, and so what I'm looking for is I'm looking for all insecure netty object creations where, and so there's a couple of different methods. So there's a couple of different constructors where this vulnerability can exist. There's the default HTTP headers, the default HTTP response, default full HTTP response, right? So those three classes, and then I'm looking for the argument, the 0th argument here, the 2nd argument here, and the 3rd argument here. In those cases, if there is a compile time constant expression where the Boolean value is false, there is a vulnerability here. When you run this query, and so what you'll see here is I have an insecure netty object creation, and this right here, right? So I had declare this abstract class. All of these three extend from that, but because of that previous thing around, Southerners that we remember from earlier on, I can select all three of those with one little from, and that will select all of those and use those as the query result. And so this is the first CodeQL query that I submitted. I don't remember, I think it was like $1,200 for this query and a little bit of documentation around it. And that was a pretty solid start to my getting into this because, a very simple, actually it started even simpler. This actually started with just, I think, like this. And I since extended it to add a little bit more, and I didn't ask for an additional bounty because I just realized that there was like more that could be covered. Like, I only found the first one and that was enough. But then I was like, oh, there's actually more vulnerability here. So I added the additional 3 cases. So that was one of them. Let's look at this next one. So one of my bits of research that I've been looking into is supply chain stuff, and in particular the supply chain of the Java ecosystem. And so one of the vulnerabilities that I poked into, did you try the netty query with data flow? I.e. when I have not tried it, and this is because I was very, very early in my experiences. I feel like you could use data flow analysis in addition there and get it even better refined. However, if you look at the number of false positives here, it's actually very, very low. Let me go back to this. So there's actually like only a very small handful of projects that give you false positives. And so I figured that just given the low rate of false positives and the number of cases where I found that having this set to false did result in a vulnerability was so high, because I got like 6 CVEs out of this, just like looking, because of that, right? Because the signal to noise ratio is so high, you have to be putting in some other mitigating control somewhere else for this to not be a vulnerability. And me trying to track down all the auxiliary mitigating controls that you may be doing, it was just more difficult. But you could do data flow analysis. The other problem is I don't think there's enough sources of user supplied data when you're interacting with Netty like this, because a lot of these are libraries. And so a lot of these libraries don't have well-defined, like, this is a data source from Spring, or this is a data source from whatever, right? So because of that, because it's not as easy to track down user-supplied data sources, it was another reason why I think that trying to do that tracking is not as useful here. Does that make sense? We good? Yeah? Okay. So second bit of research that I did, second bit of research that I did was around Maven. And so Maven has, so one of the vulnerabilities I've been finding across the Java ecosystem is the use of HTTP instead of HTTPS to download your dependencies, right? So this is about your supply chain, your supply chain for the components that you're building. And if you're downloading your dependencies over HTTP instead of HTTPS, the Java ecosystem doesn't have any other kinds of like auxiliary verifications that you're actually getting the artifact that you've asked for. And so if you do that, you have a vulnerability where you can be supply chain attacked via a man in the middle. And so I wrote up this query, and so this is an example of a Maven POM file, which is what is used for basically declaring where you get your dependent components from. With this, if you have HTTP in these various different locations, you can have vulnerabilities. In particular, this location, is where you're resolving stuff, and then these are examples of where you'd be uploading your dependencies over HTTP. And in this case, you also specify credentials, and in that case, you're uploading with credentials in plain text, right? So your credentials are exposed as you do the upload to the local network. And so the query for this is really simple, and you can see there's still so for this project, this one was a fun one. For this project, after I wrote this query, I actually wrote a bot that goes out and generates pull requests. And so for this particular project, I actually generated 1,596 pull requests to actually fix this vulnerability across Maven POM files across GitHub. And so I'm surprised to see that there's still this many. I should probably do another pass of code of pull request generation, given that it seems there's more results that have popped up. But the query for this is actually really simple too. So if your declared repository extends a POM element, which is defined by CodeQL, if you're and then you're in a repositories block or a snapshot repositories or a plugin repository block, and then I get the child element, right? So let me split this open in query console. So I grab this block, I look for the URL block, and I look for the contents here, right? Sorry. Let me split this here. I look for the contents here, and I see if it regular expression matches this insecure repository usage, and if it does, it's a vulnerability. And I think I got another couple $100 from this query submission, and then so GitHub double bountied me for this one. So one for writing the query and submitting it to the default set of queries that GitHub has, right? And then the other part was for the pull request generation, and so I generated 1,596 pull requests for this, which several hundred of which have been merged. And for that, GitHub bountied me $2,000, but because they bountied me a base $2,000, but because I generated 1,596, they actually doubled that. Because I generated so many pull requests, they doubled it because of the number of because of the number of projects fixed as a part of it, and they paid me $4,000 for this this query, or they paid me $4,000 for actually fixing it, on top of the $1,000 for so $1,000 and change for the query. Actually, let me pull up my HackerOne account. I can actually give more accurate numbers here, because that would be giving both myself and GitHub credit for where credit is due around bountying. You can, the bounties for this stuff is actually not bad. And then, on top of that, if you find enough vulnerabilities, I mentioned this at the beginning of the stream, because I found this vulnerability, because I wrote a CodeQL query that found a bunch of vulnerabilities and then threw it at all of Google's open source projects, I reported it to the Google security team, and they paid me a $1,000 bounty just for reporting the a group of vulnerable projects with the same code. I basically sent them a link to the CodeQL query and then a description of each of the projects and why I thought each one of them were vulnerable or not vulnerable, be it as it may. And because of that, they bountied me $1,000. I haven't, even sent them the thank you yet. Let me just sign into my HackerOne account.
Jonathan, when
yes.
you are looking for your HackerOne account, you mentioned earlier this POM element that is defined in CodeQL, but in fact, I want to say that as the language is extensible, this POM element comes from just the import that you see above, xml.code.xml.mavenpom, and
Yes.
Whenever there is a class like that is defined by someone else, so it might be by our researchers at GitHub, or it might be from the community, then it enriches the classes that other users can use afterwards. So it's really a community effort to enrich and enrich this language.
Yes. So one of the things that I've seen GitHub do too is, which is really cool, is you don't need to know of a new vulnerability, but if you know of, okay, this is a good set of methods that define user-supplied input. I have seen GitHub in the past, so Xavier works at GitHub, so, but one of the things that I've seen GitHub do in the past is if you just add additional inputs or outputs, and that because you've added the value of just declaring new inputs and new outputs, that results in, you can provably show that actually found new vulnerabilities and real vulnerabilities in open source software just by classifying and defining inputs and outputs of soft. So, okay, so let me break that down a little bit more for people that are new. So GitHub has, and CodeQL has this engine, and it's called data flow analysis, and they also, there's data flow analysis and taint tracking. Data flow analysis lets you define sources and sinks. I have really deviated. Give me a half second. Let me finish the Maven Palm thing. We'll go to the GitHub Security Lab. Hang on 1 second. Activity. Actually, you know what? Let me do this way. Overview. So GitHub has paid me $11,000 in the past since the program is open, which is pretty spectacular. I don't know if I can show in my settings. Swag, reputation, sessions. Alright, let me do it this way. HackerOne site is slightly slow too, which is part of the okay, GitHub Security Lab. Activity, there we go. Java. Yeah, so okay. So, for this query, right, and the associated documentation, GitHub paid me $2,300 for this query and the associated documentation and associated with it. Pretty spectacular. Very little bit of code and some documentation about a vulnerability that I'd already been working on pretty heavily. That's pretty spectacular. And then the additional $4,000 on top of that for the actual mass generation of pull requests. Let's look at another one that's a little bit interesting. What was, have I had any other ones that do data flow analysis that have been accepted and merged? Let me look real fast. Data flow analysis, Maven. I don't think I've actually had any pull requests accepted or any like bounties that I've gotten merged from actually doing data flow analysis. That's pretty interesting. Okay, so let's look at a query that does data flow analysis as an example. CodeQL J. Okay, so nope, I don't know why I'm attaching my name to that. What am I doing wrong? GitHub CodeQL. There we go. Pull requests. So, just give me a second. I want to make sure that I'm not publicly disclosing any vulnerabilities that are not already disclosed somewhere. That one's not public yet. That one's not public yet. That's not public yet. Is the Netty one? The Netty one should be... Oh, yeah. Let me grab the Netty one, because that one's actually public. Okay. Because that'll be... Actually, no. Let's do the Jetty one, because that one's really good. I like that one. That one's... I think yeah. So I've been working on this CodeQL query for a while. Come on. There we go. This is not going to give me what I want. There we go. Got it. Okay. Also, GitHub security advisories are spectacular. The formatting on this thing is just wonderful. I highly recommend you do CodeQL, or you do your GitHub, you do your advisories via that. So, this query here is doing something called data flow analysis, which is really, really awesome. An example of this is, this is very, very simple, very, very, like, straightforward, very, very stupid sort of, like, you know, this does not at all represent the power of this. But what I'm doing here is, down here, I'm defining data flow, right? So I'm defining where where a source of data, where a source of something ends up flowing and some other behavior happens on that thing. And because you don't just have just because you have a method, right? Like some vulnerabilities are you use a method, it's vulnerable, right? Some vulnerabilities are you have data where you what to do? Yeah, don't merge with this. Yes. Yeah. Thank you. You have data that flows from this location to this other location, and because of that, there is a vulnerability that exists here. One of the examples here that I have provided is in Java, there's a vulnerability that exists when you have, there's a local privilege escalation vulnerability, or sorry, a local temporary directory hijacking vulnerability that can exist when you have a pattern like this. So the pattern here is you create a temporary directory, you create a temporary file, and file.createTemporaryFile uses a secure random number generator, so you cannot predict what this file name is going to be, file. It generates that file, and then you delete that file and you create it as a directory, right? And so here in this you have a race condition. And the race condition is between this deletion and this makeDirs right here. And so because you are creating a file, quickly deleting it, the issue is makeDirs here does not throw an exception if the directory already exists, right? So if the directory already exists, it just returns false. It does not throw an exception. So between here, this delete and this makeDirs, you can have somebody else, a malicious individual, jump in there and make the directory. The thing is that when you call makeDirs, and if you are first, makeDirs will follow the uname, and so you will end up with a directory created with the permissions set by the uname, which basically usually means that that directory gives you read-only access. Additional context, taking a step back, the temp directory on Unix-like systems is shared globally between all users. So if you create a temp directory, if you create a file within the system temp directory on a Unix-like system, that temp directory is shared. So basically, if you have another user on that system and you don't create that directory or file in a secure way, the contents of that file or directory is visible to other users on that system. And so in this context, because the temp directory is shared between all users, there's a race condition where between the deletion and the making of the directory, you can race the process to try to create that directory. So what you have here is I actually detailed this in the write-up here. Yeah, here we go. So ensure that the file is only unique by this format, this syntax. Why is this not showing up right? This is an advisory that's already been published, but can I not edit? I can edit the advisory. Great. I'm going to edit this to make sure that it uses syntax highlighting that makes sense. No, it's already lit. Xavier, I found a bug in this security advisory rendering. When it's nested in a block quote like this, it doesn't work right.
Yeah. Yep.
That formatting or that syntax highlighting is not. I mean, maybe it's dark mode. I don't know. Anyways, so here, you ensure the file will be unique by appending a random digit, right? So you get a random file. And the attack, because this file is created, the attacker knows the full path of the file that will be the attacker knows the full directory that will be generated eventually, right? Because when the process deletes it, right, attacker sees the file is deleted and begins a race to create their own directory before Jetty, right? And then they make a directory with the same name, and there's a security vulnerability here because of the race condition, right? So the make ders, because the deletion, because delete came first, and they didn't check that make ders succeeded. So if the directory already exists, make ders returns false. And so because they don't check the return code to see if it's false, there's a vulnerability there. We good? Is everybody are we on the same page? Does that make sense?
We're good.
Great. Awesome. So in this query, what I'm looking for is I'm actually looking not just for one data flow, I'm looking for 2 bits of data flow, which is weird, right? I'm looking for data flow. Oh, lordy, no, please. I'm looking for 2 bits of data flow. I'm looking for data flow from this to delete, and then I'm looking for data flow from delete to make ders. So this is a little bit more advanced. I'm using 2 bits of data flow instead of 1. So let's classify the first bit of data flow. So the data flow, so all java.io.file create temp file methods. So get declaring type is, so the method, if the method's declaring type is file, and the method has the name create temp file, this is the method. And I've also written a classifier for the method makedir or makeders. They both behave basically the same way. They both need to return false, so both would be vulnerable. And then I also have a thing that defines what a delete method looks like, right? So the first bit of data flow that I'm looking for is a flow from the method create temp file to the deletion, right? So in here I define a data flow configuration, and a data flow configuration is because of reasons, data flow configuration extends string. So I need to constrain the string to be a thing, so I just give it a name. There's a much more in-depth explanation there, but this is the TLDR. And then I define a data flow source as a method access. So this is a method is different from a method access. A method exists because it exists in source code. A method access exists because it is a call on that method. Good? Yeah? And so there exists a method access, and the method is an instance of the file, the create temp file, right? So this is all create temp file methods, right? And there's actually 2 of them. They're overloaded. It's an overloaded method, but both of them are vulnerable potentially. And so I'm looking for a source where the source, as an expression, is this method access, right? So I have captured this, basically. And then a sync, in this case, is a delete file expression. And so the sync is delete file expression, which I've defined as a method access where the expression qualifier, so the expression is the it's not the sync is not the delete method itself. The sync is the call upon tempter. So it's not, the sync is not this. The sync is because this thing is being acted upon. It is the sync, right? And so because of that, I capture that it's the qualifier. And then I also say that this method access is of type method file delete, which is the delete method here, which I defined above. So that's the first step, right? So I'm tracking the use of this to delete, and then I also need to track from delete to makedir or makeders. And so what I also track is the source. So is the source, is file, is delete file expression. So I create another source here, which is we went through that before. So we're now starting at delete, and then the sync is the method access of makeders, right? So I'm calling the makeders, which is either makeders or makedir, right? And so this is where it gets a little bit wacky, because so I can't define so there's data flow configuration, but because I'm defining two different flow configurations, I can't do this. I can't extend it here because I'd be double constraining what a data flow configuration is. So what exists in the CodeQL library, again, this is getting a little more advanced. There actually exists multiple copies of the data flow library, and for syntactic reasons, I have to use the second version of this library to do to create the second constraint. Is there like an ELI 5 version of how to explain that, Xavier, or have I done a good enough job?
I think that's good enough. It's a bit hairy, but that's normal.
Okay.
I don't think we can simplify it more. If
you need more help with this topic, I'm available on Twitter or anywhere. And so I'm then defining the sync, right? And so down here, yeah, so this is another check that is not finished. This actually is in my pull request. I need to make this better because it's not good enough to actually hold muster. It was good enough to find this vulnerability though in this particular case. So what we create is we pull a data flow source, and then I pull another one which is the delete checkpoint, which is so I'm creating a checkpoint halfway through. And then I create another one, which I'm also gonna have be the same delete checkpoint. But in the other version of the library, so that I can use it. And then I will further constrain that later. And so I have dataflow to sync, right? And then I then grab both of those configs in scope so that I can use them, right? And so then my query is where the toDelete config has a flow from the source to the delete checkpoint, and so that's this first bit, and the from delete checkpoint, right? Sorry, this one down. No, from delete checkpoint config has flow. So I'm looking for flow from the delete checkpoint to, so that's from here to here. That exists, right? But as additionally, because this delete checkpoint and this delete checkpoint are not the same checkpoints, they're from different libraries, I need to further constrain them so that they are equal to each other. And so I then get the delete checkpoint as a node and then as an expression, and I make sure that this version from the first copy of the library is equal to the second copy of the library, so that further constrains it to make sure that I'm looking at the same chunk of code for data flow. And then I look to make sure that the sync is constrained by an if check. So the sync being this makeders. This is very naive. Basically, if you wrap it in an if check, you're safe. But I found that to not always necessarily be true. So I need to be more I need to do more condition checking there around that to basically say you're only safe if you are using it, if you don't use it in the false case. Basically, if it comes back false, you continue like in the happy path, there's a vulnerability there potentially. And so then I select the node, and then I define the source and the delete checkpoint. So what you'll see here is what actually happens is I can show the path, and this path can get much, much longer, right? So I can have, like, there can be up to, I don't know if there's an upper limit on how many steps, but the CodeQL language can track data flow through, like, just tons of assignments, and if you use, so the data flow does a lot. Then you can also use the taint tracking engine, and the taint tracking engine will track your data through string concatenation, through it being added to a file, through a lot of different things, like being used in a string builder, stuff like that, where your data gets combined with other data, where because that even though your thing has been combined with other things, there's still a vulnerability there because for example, right, like an SQL query or an SQL injection vulnerability, right? SQL injection vulnerabilities exist because user supplied data is concatenated with other external strings, right? Internal strings, and then all of that data is bundled up and shipped and submitted into a place where SQL is executed, right? And so because that at that point it's not data flow, it's taint, right? You have tainted user supplied data that is appended into an SQL query, and that at that point it syncs into an SQL point. Brain. Wow. Whoop. As a result of that, that you can get data flow that like goes through multiple layers of your software stack and ends up being syncing to an SQL injection point. And the CodeQL taint tracking can show you all of the multitude of steps that are involved in that. And that's really, really, really powerful. I've similarly been able to use that to track down some other pretty convoluted vulnerabilities and some pretty complex stuff. Xavier, do you have any like off the cuff examples of like good examples of like multi-step taint tracking or things that you'd recommend that I show off real quick?
Real quick, no.
Okay.
Off the shelf, sorry. But yeah, I think in the various CTFs that we have on our side, or I don't know what other examples we could show real quick.
So
well, continue like that, and if I see one,
yeah, you'll ping it to me. Okay.
Yeah.
So what you'll see is one of the limitations is that I can't actually show the full path, so I can't say that this to this to this is a vulnerability in code. Like what I found the vulnerability, right, and which is a valid location, right, but I can't in this rendering here, I can't show all of that information, unfortunately. I can only show the paths where this comes from and ends up here, with the inference of it ending up being further on in the code. If that sentence didn't make any sense, don't worry. After I said it, I also kind of went, "Oh God." Yeah. So this is a bit of security research that I've been using, and I've been using this to find temp directory hijacking vulnerabilities. And the implication for this vulnerability in Jetty, in particular, and actually in a couple other places that I found it, is actually local privilege escalation. Because you'll find that a lot of cases, there's software out there that the reason that they need temp directories, so the common usage for a temp file is to store temporary just stuff. You need to throw stuff in a file. But actually, interestingly enough, one of the common reasons you'll create a temporary directory is because you're going to write code to it and then execute it, right? And so if I can hijack your directory, so okay, a little bit more context. When I beat you to this make ders, I'm beating you, but I'm creating that directory with more open privilege, with a wider set of permissions, right? File permissions, such that your user and my user can both edit the contents of that directory, right? And so because I can hijack your directory, I can increase the permissions on that directory. I can then access anything inside that directory. If you are writing and executing code out of that directory, I can then write my own code into that directory and run it. And suddenly I've got local privilege escalation because I'm now running code as your user that was just thinking it was running code out of a temp directory. You're now running my code that I, as a malicious user, have given you in your temp directory to run. So in this Jetty case, that was actually local privilege escalation in this case, which is pretty cool. Not good, but pretty cool that's what this vulnerability is tracking down. The other one that I found a lot is that this API, so this is the other one that I've been tracking down in source code, is if you do use this API, this file.createTemp file. What time is it? Just do a time check because I don't want. So it's about 8 o'clock. So I'll wrap out about around 8 o'clock. So this file.createTemp file, this method in Java returns a file with the permissions defaulting to what the uname is, what your uname setting is. And so by default, the file created has the read permission set for all users. And so if you stick sensitive information inside of that file, right? So outside of this vulnerability, if you just use the file that thing returns, when you shove information inside that file, if there's any sensitive information in that side of that file, it gets publicly exposed to all users on that system, instead of just being restricted to the single user. And so that can be local privilege or that can be local information disclosure. So, that's, again, pretty cool. Again, also only on Unix-based systems, because the Unix-based systems are one of the only ones that share a temp directory. Mac OS does not do that anymore. And, new modern versions of Mac OS don't do that. Linux Windows is also not vulnerable. The interesting thing, though, is the file that this returns on Android is actually pretty interesting. If there is an SD card on the Android device, this can return the SD card, and the SD card is no matter what permissions you set on the SD card, that SD card gives you anybody can read the contents. I think that's only in the old versions of Android. I think that the newer versions of Android's fixed that. There's an open issue with Guava about that. So, are there any other ones that are really interesting? Oh, you know what? The one that I like, I'm just gonna demo this not for the CodeQL query, but just for my computer is being slow. My computer is being very slow. What is going on? My fan isn't even spinning. My computer is... Oh, what? Oh, I'm on 5% battery. That's weird. Alright, let me... Alright. Is the stream still going? Great. I think that'll fix that. So apparently I was running the power through my dongle, and it was not apparently putting up enough power for everything that was going on. Okay. Let's just look at this one real fast, because this one's fun, and then we'll be done, because I'm tired. Calls to eval like dumb function. So this is an example of cross-site scripting that you can get in JavaScript, and I actually found a vulnerability in a project called Mongo Express, which is a MongoDB user interface that I found. If you look on Shodan, I could find a bunch of these things publicly exposed to the internet. And so this vulnerability I found by scrolling through. So you see these alerts? I just scrolled through pages of this and just looked for interesting projects. And I finally found one project called Mongo Express that had this vulnerability. And lo and behold, because of where it was, it actually ended up not being cross-site scripting. It ended up being remote code execution vulnerability. And because Mongo Express didn't have or had default username and password by default, when I found these servers on Shodan, I could just log into them and I could have dropped RCE on them whenever I was like, okay, I'm not going to drop RCE on these, but like I could drop RCE on these because there was a query console that was interpreting Mongo Express query language and running it, and if you dropped JavaScript inside of it, it would just execute it on the system. So this is not paths. I thought this was going to show us paths from user supplied data. That's not code injection. Is this one going to show us paths? Yeah. Okay. So here's a better example. So you can see so model name. I'm guessing this is like Dojo or some language that, because you define this method, it maps to some get request, right? And so because of this, there's data flow analysis where it's tracking from this thing that's coming from a user, right? Yeah, because it's a request. So the model name that comes from the user, that's appended into eval, and because of that, you've got our code execution vulnerability. So that's 2 steps. Okay, you can have multiple steps of this sort of thing. So while I'm here, I'm just going to kind of open it up. Any questions before I shut her down? Anybody in the stream? Anybody here? I've lost both people from the Zoom, or well, almost all the people from the Zoom call.
Jonathan, I sent you an example with more steps. Well, show it super quickly because I didn't have time to check if it's real or not. Well, cool. It's public on HTML, but
Yeah, where'd you send it to me?
On the Zoom chat.
Oh, in the Zoom chat. Let me find that. More chat. There we go. Okay, there we go. So this one has awesome. So this one's an SQL injection vulnerability where user supplied data supplied from these API parameters. So because these are, so I'm guessing this is like Spring annotations or something like that. You can see that the data comes from there, and then you have multiple steps where the data flow happens, where it gets passed into this history query DTO, right? Yeah, so it calls the setter on this the user supplied data gets passed into this setter on this this POJO, plain old Java object, right? And then that object flows. Oh, that's cool. I didn't know that actually worked. And so that object flows all the way down and into this prepare SQL statement. And because of that, there can be a vulnerability there because of user supplied data flowing to this prepare SQL statement. So that's an example of multiple steps of data flow. Yeah. Any questions on the stream?
Yeah, Jonathan, I'll put you on the spot for a half second.
Go for it.
Given that you have used this a number of times to report and record vulnerabilities, is there anything you see that would be really useful to you and to anybody using this tool in improvements and usability, or anything that you could see this tool doing in the future to make it more available and easier to use?
So there's a couple of things that are really cool. So as a part of this, so LGTM.com is really cool because by default, if you import a project from GitHub, it can most of the time auto run it, but it doesn't build everything, right? So there's certain cases, like I think that it doesn't automatically work with Java versions. If your project depends upon a version above Java 8, it doesn't automatically work. Because it assumes that you need Java 8 and it only runs with that. But for a lot of projects, you can just drop it in and use it. And then Also, you can enable it on your project to automatically scan your pull requests against that open source project. Additionally, GitHub has GitHub Advanced Security for running these against your closed source projects. And you can, establish a relationship there to get this to run against your closed source projects. I think that so one of the things that I have needed, right? So around usability, at least for who's the usability you are talking about for security researchers, for maintainers who are working with the tool. I have my own set of features that I would love as a security researcher to make my life easier that I've managed to hack together. I've written a bunch of hack scripts to import a bunch of projects to be able to do bulk security searches. But like, who's the user that you want to prove for, Seth?
Well, it's you are the primary use case that we're talking about here. So anything that you have seen. So obviously gathering your repositories is something that might be something of a pain point, but I just wanted to hear if you had any other ideas.
Yeah, so I've written some scripts, some Python scripts that you have to I basically use LGTM's internal unpublished API, and I send a bunch of post requests that you would normally use the user interface to do. I just do that all automated with some Python scripts, and that's how I'm able to bulk import a bunch of projects. That would be really useful. The other thing that I've found, at least in the lgtm.com website that's been kind of annoying is I remember I was talking about how I scrolled through pages and pages of results to find that. I think I spent 2 hours or an hour and a half just looking through projects trying to find an actual project that actually had a vulnerability, that was worth reporting for CodeExec, and I finally stumbled across Mongo Express. That was, I feel like sorting these projects in some way, either by star count or one of the ones that's really interesting is the Open SSF project has this criticality score that they've rolled out. And so I think that sorting these projects by criticality score on lgtm.com, once that standard is rolled out, would actually be really, really useful, because it then brings to the top the projects that it's worth it to report these vulnerabilities to. Because there's a ton of vulnerabilities, a ton of projects, right? But some of these are just one-offs, right? They're one person's project that they used as a demo or it's not worth your time to report to those. Unfortunately, right? There's only so much time you have in a day. And so surfacing those important projects and also making it easier for security researchers who want to get involved in this to not have to bootstrap their project, I've done a bunch of hacky stuff to my GitHub, to my LGTM account to get my account into a state where I can use it to do this sort of security research at scale. Kind of making that onboarding a little bit easier would be appreciated. Or, you can also send me a Twitter DM and say hey, I want to get my account bootstrapped, help. But, I think that having that be an easier onboard for... Because the people that work at GitHub and are part of the GitHub Security Lab, they have a button. I've talked to them. They have a button which says run this query against all projects, and it just automatically runs against all 17,000 Java projects that they have imported, or stuff like that. And I only have a couple of thousand imported under my account by default, so I'm running under a very small subset. But I've narrowed what I'm trying to go after. So also sorting. So I've had to I don't know all of the projects that are owned by Google, so I've had to slowly create a list of okay, these are all of... So Google has multiple GitHub organizations, which is you think one company, but actually that one company has multiple organizations on GitHub. And so I've had to as I've looked at Google, I've had to, there's another one over here that's a Google project. I should add that to the list of organizations that I scan. I actually did contact Google's security team to ask them hey, can you give me a list of all of your projects, because I'll just scan them when I'm doing my security research if you want in the future. And so that's one of the vectors that I've gone through. So just determining what is important is hard. Determining what projects have bug bounty programs can be difficult. Yeah, but the scope on this bug bounty program is so huge. The vulnerabilities that you can find are just wild, right? And it's I think this bug bounty program has one of the widest scopes for bug bounty programs that you could ever find, right? Like it's basically like, here's all of open source that is on GitHub, which is like several million projects. Like, go find common vulnerability patterns that you see repeated again and again and again, and like encode that knowledge in a CodeQL query so that people stop making these mistakes, because it keeps happening. And like the security researcher community does not scale well. So this is like finally a way that like our knowledge can scale in a decent way. So yeah. That's a long-winded answer to your question.
Well, thank you.
Yeah. Anybody else on the stream? Hope to see more streams about CodeQL like this. I'm glad you guys enjoyed it. 7 people, but like, and plus a couple people on the Zoom call. I'm glad that I hope that this gets more people into this, because it's fun and your research really does scale. And if you want to do bulk pull request generation, like you want to generate thousands of pull requests because you find something that's that repeated and that common of a vulnerability, hit me up. I have a bot that does that, and my account. You want to see my GitHub account right now? It's really funny because I have so many pull requests and so many forks. This is my GitHub account right now. Let's see if it does it. If it loads correctly. All right, let's see. And don't make a liar out of me. Oh, it actually loaded. Okay, so most of the time my GitHub account is the angry unicorn, which I can actually trigger. I can trigger it. So this is, I'll show you what my account normally looks like. Yeah, here we go. This right here. This is what my account normally looks like when you load it for the first time before it gets cached by whatever your local CDN is. Oh, it actually, what? No, it didn't fail. It just, nope, wait, what's it gonna do? Is it actually gonna load? Nope. Usually you get the angry unicorn. Oh, it actually loaded. Oh, they fixed that. Oh, great. Okay, I get to close the support ticket. Yay. Nice work. Yeah, I'm used to getting whenever I tried to load that in previous, I got the angry unicorn. So, there has been some progress on my GitHub account. My GitHub account still takes like 20 seconds to load, though. Let me just reload this real fast, because this is just kind of fun.
Looks like you're disappointed. I can bring back the unicorn.
Well, you're making a liar out of me. So these are my 2 bulk pull request generation days. 701 contributions, 1,024 contributions, and then this other one over here, 3,776 contributions. Those are my 3 days that I did bulk pull request generation for security vulnerability. So, all right, it is late. I'm tired. I've had a long day. Thank you all for coming. Thank you for enjoying.
Thank you, Jonathan.
Yeah.
It was great.
Yeah. Hit me up on Twitter, JLightShoe. I'm happy to talk more and help to put people in contact with anybody. Yeah. Thanks all.
Yeah, thank you, Jonathan.
Yeah. All right. I'm going out.